everyone, welcome to OneClass livestream. This is Chang, and today we're going to talk about some commonly asked math problems. So let's get started. Cool. So the first problem we have today is asking us what is the formula for the surface area of a cylinder. There are two main approaches you can do that. Usually you would just write down the formula of the surface area of a cylinder and you just use it. But in case that you don't remember what the surface area of a cylinder is, because there are a lot of formulas to remember or to memorize, you can just quickly derive it. I'm just going to walk you through the process of finding the formula for the surface area of a cylinder, so like next time you know how to solve similar problems. Alright, so let's get started. So first we have a cylinder right over here, and we know that the top of a cylinder is a circle. So let me just draw it in blue actually. And this would be the radius of the circle that's on the top of the cylinder. Then we also have the height of a cylinder. Let's just draw it in green. So this is the height of the cylinder. In order to find the surface area of a cylinder, you need both the surface area of a circle. So you need to know the formula for the area of a circle and the formula for the area of a rectangle. So let me just write down what the area of a circle is. I'll just do the area of a circle of C, because I don't want to write down circle more than once. Okay, so the area or the surface area or the area of the formula for the area of the circle is just pi r squared, where pi is the irrational number 3.1415 blah 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 blah, and r is just the radius of the circle. And this is the formula for the area of the circle. And you probably already know that the formula for the area of a rectangle, so let's just do A of r, it's width times length. Now, immediately you could see that our area of a cylinder, so our area of say cylinder is equals to the area of this, is equals to 2 times the area of the circle plus area of the rectangle. You might not see the area of the rectangle right away. So you know what, let me get a piece of paper. So say that we have a circle, or we have a cylinder like so on this piece of paper. So if you look at the camera, you can see this is kind of a cylinder. So say you have a cylinder right over here. You know that the top part of the cylinder is a circle and the bottom part of the cylinder is a circle, which is also shown on our screen by the circle right here above and the circle right below. And that's why we have two of the area of the circle, because the area or the surface area of the cylinder is this entire part in the middle here, plus the top circle plus the bottom circle. And that's how we find the surface area of the cylinder. So now you know that the surface area is 2 circles on the top and the bottom of the cylinder, and also the area of the side over here. So imagine the cylinder is actually imagine you're like wrapping the gifts that you're going to give to your friend for Christmas or for New Year. So how would you use the wrappers to wrap the present around? You would use a piece of rectangle paper to wrap around your present, and you have a circle at the bottom of the present and at the top of the present. So here is actually a cylinder that I have just briefly made using a piece of rectangular paper. So imagine that you're cutting through the cylinder on the side over here and you're opening it. That would be a rectangle. So yes, magic, right? So, but how do you know what is the area of this rectangle? Because you know the area of the circle would just be the area of this rectangle around the cylinder plus the area of the top circle and the area of the bottom circle of the cylinder. So how would you find the area of the rectangle wrapping around the circle? You would know that the width of the rectangle or the height of the rectangle depending on how tall the cylinder actually is. Or in this case, it's our width. Our width is just the height of the cylinder, and our length is actually the circumference of our circle at the top. So if this cylinder is actually wrapped around in a gift wrapper, a piece of paper, or a piece of gift wrapper, and you're opening it slowly, you would notice that the length of the cylinder is the circumference of our top circle on the cylinder, and the width of this rectangle is our height of the cylinder. So yes, that's how we find the area of the cylinder. And we just need to know another formula for the circumference of the circle, which is 2 pi r. So now, let's just draw this in red over here so that it corresponds. And let me erase this black circle over here. Perfect. Nice. All right, so we know that the area of the surface area of the cylinder is equal to the area 2 times area of the circle, which is just 2 pi r squared, plus our area of the rectangle, which again it's just width times length, but our width over here is actually the surface or the circumference of the top circle or the circumference of the bottom circle. They have the same circumference. So we just need to do 2 pi r as our width of the rectangle, which is also the circumference of the circle, multiplied by our length of the rectangle, which is our height of the circle. So here we have the surface area of a circle, and we just need to simplify the expression a little bit. So we have 2 pi r squared plus 2 pi rh. And if you're factoring out the common factor, here we have a common factor 2 pi r. So if we factor the 2 pi r out, we have the area of the surface area of the cylinder is 2 pi r multiplied by r plus h. And this is our formula for the surface area of the circle. And let's use a highlighter just to highlight it. This is our final answer. Perfect. All right, now let's look at our sample solution over here on our left-hand side. Yes, they also derived the surface area, except they didn't give much of an explanation for the lateral surface area of the rectangle, or at least they didn't give as much explanation as we did, but that is completely fine. So let's just say the answer is correct. Our answer is correct. Great job. Perfect. So this is our first problem right over here, finding the surface area of a cylinder. All right, our next question is asking us how many faces, edges, vertices are in an octagonal prism. So before asking this question, we need to know what is an octagonal prism. So in case you don't know, we first need to know what is an octagon. So octagon is just a polygon with 8 sides. You might think octagon as a polygon with 10 sides because October is the 10th month of the year, but the calendar month of October is another story because it got bumped up by 2 places. It's an interesting story for the month of October, so if you're interested, you can look it up. But going back to our math problem or our octagon, the octa is actually 8 in Greek. So our octagon is a polygon with 8 sides, not 10. This is like what you need to remember because a lot of people got confused by it and they thought octagon is a polygon with 10 sides, but no, it's a polygon with 8 sides only. And an octagonal prism is just a prism with its top and its bottom as an octagon. I'm going to try my best to draw octagon, but it probably would be really hard when to draw an octagon for me by hand. You know what, let me just find an octagonal prism. Octagonal prism photo. And then let me just show you this photo. Okay, here's a photo of an octagonal prism. And let me just click on it. Perfect. So this is our octagon, our octagonal prism. A prism that has 8 sides, 1, 2, 3, 4, 5, 6. Perfect. Actually, let me just use this photo because it looks better. Also, it's kind of looks like a drum, which is even better. Yes, it's asking us the faces. So let me just write it down over here. The faces, edges, and vertices. So let me do faces. Faces. We know that a face of a geometric shape, it just means one of those kind of one of the side. It just means side, except they call it faces in math. So this is one face and this is another face. So for octagonal prism specifically, we know that there are 2 faces at least. One is at the top, which is an octagon. The other one's at the bottom, which is another octagon. So we know that the faces is actually 2 plus the faces on the side here. So we know an octagon is a polygon that has 8 sides. So it has 1, 2, 3, 4, 5, 6, 7, 8 sides over here. And each face of the octagonal prism on its side, like so, actually has one of its width as the side of the top octagon and the bottom octagon. So since the octagon has 8 sides, we would have 8 faces or 8 rectangular faces on the side of the octagonal prism. So in total, an octagonal prism has 8 plus 2 or 2 plus 8, which is 10 faces. Then the next question to ask us is how many vertices octagonal prism have. So let me write down here vertices. So for those of people who don't know what a vertex of an octagon is, a vertices is, it's just like a top point over here. That's where multiple sides of a geometric shape comes together. So this will be a vertices. This is another vertices, another vertices, another vertices. So an octagon or octagonal prism, again, it has one octagon on its top, one octagon as its bottom surface. And we know an octagon has 8 vertices because octa again is 8. And we also know that we can count the vertices like 1 set of vertices and then 2 set of vertices on the bottom of the octagonal prism. So we actually just have 8 plus 8 or 2 times 8, which is 16 vertices for the octagonal prism in total. Next up, let's count the number of edges. For those of you who don't know what an edge is basically like a line like so, or whoopsie, I don't know what's happened. Let me close it. So an edge is basically a line like so, or like this, of a geometric shape. In this case, we can count the edges, or the number of edges at the top, or for the top octagonal of the octagonal prism. And we know an octagon is a polygon with 8 sides, so obviously it has 8 edges on top. So we have 8 edges on top, and also 8 edges on the bottom, because the bottom is also a polygon, or specifically an octagon. Then we need to count the edges on its side. We already know that an octagon has 8 vertices, since each of the octagon on our top and the bottom corresponds to one of the vertices, or each of the octagon on top and bottom correspond to one. Each vertices of our polygon on the top and the polygon on the bottom corresponds to like one edge over here. So we know that on the side of this octagonal prism, we would just have eight edges. So in total, we have 8 plus 8 plus 8, which is 3 times 8, and it's 24. So we have 24 edges for our octagon, and 10 faces for our octagon, and 16 vertices. And this is our result, our final solution. So let's look at the sample solution over here. It also has a photo of an octagon, which is perfect. It mentions that it has 10 faces, which is good. 24 edges, perfect, and 16 vertices. Great. So the answer or the sample solution here is correct. So let's just say it's correct solution, or the solution is correct. Is correct. Excellent job. I just want to give you another side note here. So for this problem, it was octagonal prism was specifically asked, but there's probably like a quick way to, or a formula to find the faces, vertices, and edges for octagonal prisms. So in case you're faced with something that has like 22 different sides, or a number that's really large and you can't count it, you could also use the formula instead of physically counting it, or you can reason through it, like the process that we did. Okay, cool. Now let's go to our next problem, or our next popular question that was asked. So our next problem over here is asking us, what is the product of the square root of 30 and 6 times the square root of 10? So first, this is kind of like a word problem-ish that has to just translate it into formula. So first, it's asking of us the product. So it's which means multiplication. So it's one number multiply the other. Second, it's telling us the product of the square root of 30. So we have the square root of 30 over here, and 6 times. So it's the square root of 10, which is 6 root 10. So it's basically asking us root 30 times 6 root 10. So in order to multiply those things together, we just multiply the parts in the square roots with the other parts in square root, and we leave the 10 or leave the 6 alone on its own, because the square root of 30 is implicitly 1 times the square root of 30. So we just multiply the 1 with the 6, which is still 6. And we have 30 times 10, which is 300. Now, you might be tempted to just leave the answer like this. However, what's inside of the square root can further be simplified. So if your teacher or if your marker is not too lenient on simplification, or it's kind of like, a little more strict, you might get marks deducted. So let us simplify the square root, or the radical over here. Cool. So in order to simplify the radical, we use prime factorization. So we factor everything with like prime factors, and the smallest prime factor we can see upon inspection is 3, because we know that the sum of the digits of an integer, or the sum of the digits of a natural, or the sum of digits of an integer, if that is divisible by 3, then this entire integer would be divisible by 3. To calculate the sum of the digits, we just add all of the digits together. So 3 plus 0 is equals to 3, which is divisible by 3. So we know this number 300 is divisible by 3. And 300 is very straightforward. It's just 3 times 100, which we can separate the 2 by root 3 times root 100. And we know that the square root of 100 is just 10. So we have 6 root 3 times 10, which is 60 root 3. And that is our final answer right over here. And that is the product of root 30 and 6 root 10. Now let's look at our sample solution. So they also translate into a word prop or into a formula, which is your logical first step, and they simplify the radical, and they arrive at the same answer as we did. So their solution is correct. Let's just say the solution is correct. Yay! Cool. Now let's move on. Our next problem is actually asking us for a definition or more of an explanation, since it was asked to us. So let us define midpoint, or let us explain midpoint a little bit. Let me write the question number, or I guess there wasn't really a question number. I just like to do the questions in numbers. So our fourth question over here, what is a midpoint? So a midpoint is at its core a point, which is obvious because it's called midpoint. So it's probably a point instead of a line. But basically, a midpoint is very logical sounding, or it's actually really logical, has a really logical definition, because mid is half, point is a point. So a midpoint is actually just a point that divides a line segment, or divides a line or a ray, depending on how you call it and where you're from. So basically it's a point that divides a line segment in half. Line segment in half. So say we have a line segment right over here, and what this point right over here would be the midpoint of this line approximately, because it divides the blue line segment in half. And that is what a midpoint is. And that's all there to it, to the definition of the midpoint. And let me just give you a really common area where really common kind of type of question, or a common area where midpoint was asked, or like where you were asked to find the midpoint. So if you're grade 9 or 10, or maybe even grade 8, or even grade 7, depending on how fast your curriculum goes. Or so if you're in secondary school, ranges from grade 7 to 12, a really common question asked is asking you to find the vertices of a parabola. So what a parabola is just a function that has a graph like this. So usually how to find the vertices of a parabola is just the top point right over here of a parabola. So in order to find the vertices of a parabola, what you do is you find the x-intercepts, or the two intercepts that reaches, or where the line touches the x-axis, so where y is 0. So after you find those two x-intercepts, you're just trying to find the midpoint of this line right over here. So you're trying to find the midpoint of this line over here. And then from finding the midpoint of this line over here, you can find the x-coordinates of the midpoint. So you would find the x-coordinates of the midpoint of these two zeros of your function, and then from this x-coordinate of your midpoint, you can plug it into the function, and then you can find the y-coordinates of this point, of this x-point on the function. And this x and y coordinate pair is your vertices right over here. Really straightforward, right? So yeah, this is a really common area where you are asked to find a midpoint, and it's a really common problem on your exams or in school curriculum. So yep, and here's all I'm going to cover about the concept of the midpoint. Let's take a look at the sample solution given. They just defined the midpoint on the actually, I guess, wrote down the formula, but it's just really easy because you add the x coordinates of the two points together, and then you add if you want to find the x-coordinates of the midpoint, you just add the x's together and divide by 2. If you want to find the y-coordinates of the midpoint, you just add the y-coordinates together and divide by 2. So yeah, and they also give an example, which is just basically plugging numbers into the formula. They didn't mention about parabolas, but again, that's a expression, or that's just an extension. So let's just say correct solution. Yay. And the solution is correct. So here's our next problem, and it asks us what is the quadrantal angle, or what are the quadrantal angles? So what are the quadrantal angles? This is actually one of falls under the umbrella of trig, so like trigonometry. And let me just give you our unit circle right over here. Our unit circle. I'm not gonna draw the actual circle because I'm really bad at drawing circles, especially if unit circle is like a regular circle. I guess all circles are Alright, it just depends on how you look at circles. So basically, this is the unit circle. And this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. The quadrantal angles are actually angles that marks the border of the quadrants. So let me draw them. So the angles right over here would be a quadrantal angle. The angles that mark over here would be a quadrantal angle. The angles over here would also mark the quadrantal angle, and obviously the angles over here would mark the quadrantal angle. You might be like, where are the angles? Well, this is basically just the angles that goes like this for the second quadrant, and like this for the third quadrant, and then so it goes around 360 or 2 pi radians angle over here, or the 360 degrees or 2 pi radians angle over here. Again, they're like angles that goes around one times the circle, and then another half of the circle. This is also a quadrantal angle because it also marks the coordinates, it also marks the quadrants of this unit circle. Because those angles marks the quadrant of the unit circle, so they're called quadrantal angles. This is quite easy to remember, and as you can see, this can go on and on and on because you can go around the circle for infinite many of times. So there are infinite number of quadrantal angles. But the most common four are just the one that goes through here, the first one, the second one, the third one, and our fourth quadrantal angle over here. So those quadrantal angles are actually 90 degrees. So the angle that goes through from here to the y-axis is 90 degrees. And then our 90 degrees are pi over 2 radians. And then the second quadrantal angle that goes to a flat line over here is 180 degrees. Or, I'm sorry, the 90 degrees is actually, yes, it is pi over 2. I am correct. And then the angle that's 180 degrees is just pi radians. The angle that goes 3/4 of the circle is 3 pi over 4. Or, I'm sorry, 3 pi over 2 radians, which is 270 degrees. 270 degrees. And the circle, the angle that goes all the way around the circle is 360 degrees and 2 pi radians. Perfect, and these are our 4 most common quadrantal angles, and they're basically just angles that marks the border of the quadrants in standard position or on the unit circle. Nice. And obviously, it can go on forever, so like the next quadrantal angles, as you anticipated, will be 5 pi over 2 radians, which is another 90 degrees, so 360 plus 90, which is 450. Yes, and this again just goes on and on and on and on. Yeah, and that's all I'm going to cover for the quadrantal angles. Let me just look at the sample solution over here. Yes, they had definition of the quadrantal angles, And they didn't mention that the angles can go, there can be like a lot of different quadrantal angles, and it can be like infinite any technically, but I guess these are only the four ones you'll probably see. So just covering these is sufficient. Let's just say correct solution. Excellent. And the solution is correct. Now, we're at our sixth problem over here. So our sixth problem actually asks us to find the area of a hexagonal pyramid. Did it give us a photo of the pyramid? Yes, that's perfect. Cool. So let me just write down here, or I'm sorry, it's asking us to find not the surface area of a hexagonal pyramid, but the volume of a hexagonal pyramid, which is actually a little bit easier than finding the surface area of a quadrangular or hexagonal pyramid for this for this question or for the given information. So we're asking us to find the volume of a hexagonal pyramid, and again pyramid. Cool. So again, the bottom of this pyramid is a hexagon, and that's why it's called a hexagonal pyramid. Just want to let you know that. Although you can probably like just see it from the photo, or you probably already know that. So in order to find the volume of a hexagonal pyramid, our formula is just 1/3 of the area, or of the area of the base, times the height. So let me just write this or put this formula in another color so you can see it easily. Cool. And this is how we find this is the volume, or this is the formula for the volume of a hexagonal pyramid, or just a pyramid in general. And in order for this questions, or for this situation specifically, we were actually given the surface, not the surface area. We're actually given the area of the base, so like the base area over here, and also the height, which is the altitude. So we can just directly plug the numbers in to the formula and arrive at an answer. So we know the area of the base, or the surface area of the base of the pyramid is 41.6 square centimeters, and the height is 3.7 square centimeters. So this is our answer right over here. In this case, you can do it by hand, but it takes a while. So I'll just use our calculator, which right over here, I'll just type the numbers in. So we have 41.6 multiplied by 3.7, and then divided by 3, which is, by the way, because we're doing it, because this is all multiplication and division, so the order of operation doesn't matter, and we can just type into the calculator like this. But usually when you're typing your question into a calculator, or typing your expression into a calculator, be really careful, because if you type it wrong, then get the question wrong, it's kind of sad, because you already know how to do the question, but you just use the calculator wrong, which makes you really close to the right answer, but still got the question wrong. So let's see. Yeah, so this is just the volume of the hexagonal pyramid, and let's just say the area of the hexagonal pyramid is 50.1.3 square or centimeters cubed. So let's just use centimeters or centimeters cubed. Usually, depending on like which school system and everything, but usually for word problem, you'll write down the answer in like another sentence, telling them what is the area or what is your answer. In this case, we have volume, which has units of length cubed. So, and our units here is centimeters. So we have our volume is centimeters cubed. Be really careful when you have word problems. Be really careful of the units, because if they're in different units, you can't just do the calculation directly. You need to convert them into the same units first, or else you're going to get the question wrong. All right. So let's look at our sample solution. They use the same formula, and they arrive at the answer 51 cubic centimeter, which is perfect. And this question didn't, yes, this is all we're going to do for this question, of finding the volume of a hexagonal pyramid with given base area and height. Let's just say, great job, your solution is correct. And let's move on to our next problem. Okay, our next problem is asking us to find the exact value of cosine of 3 pi over 4, I believe. But it's really odd because the formatting has like a space in between them. So yeah, the formatting is a lot odd. But wait a second, I think they're actually asking us to find the cosine of negative pi over 4. Yes, so if you zoom in a lot, you can actually see a negative sign right over here, but it's colored in really, really light gray. So I guess it's just not like bad formatting, but they just changed the color of the negative sign to really light gray for some reason. So I guess we can just do both, or I guess I'll just do like negative 3 pi over 4, because the negative sign does exist. It's gray, and I can see it when you zoom in. I'm not sure if you can see. You can probably also see it on the video, but yes, if you have like, yeah, you can see like the color is in really light gray, and it's kind of faint, but it does have a negative sign in front of it. So let's just find our value, or the value of cosine of negative 3 pi over 4. Cool. So first of all, we need to find our reference angle, which in this case, we first need to find the positive coterminal angle. If you can't directly see the reference angle, but if you're more experienced, you can just see the reference angle is pi over 4. But let's just add 2 pi, so negative 3 pi over 4, negative 3 pi over 4, plus 2 pi, which is 8 pi over 4, is just 5 pi over 4. So we have 5 pi over 4 right over here for our for like a coterminal angle. Next, we just find our reference angle, which is just pi over 4. And let's actually plot 5 pi over 4 on our unit circle. So we know that 5 pi over 4 is larger than pi, so because this fraction, the numerator of this fraction is larger than the denominator of the fraction, which means that the fraction has more than 1. It's more than 1, so it's more than 1 pi. So our 4 pi, but it's not as large as 1.5 pi. So it's not as large as 3 pi over 2. So it should be around here. And this is the angle that we're interested in looking for, which is 5 pi over 4. We also know that this angle is in our third quadrant. So we know that cosine is negative in the third quadrant, so we know that our cosine value is negative. Next, let's find the cosine of pi over 4. Looking at the angle pi over 4, we know that we just need to use our special triangles right over here. And we know that the special triangles, or this special triangles, has 45 degrees, or have pi over 4. So we should use this triangle over here. I'm just going to write it down as pi over 4 because the angle is giving you radians over here. And we know that cosine is equal to adjacent over hypotenuse. So you use the adjacent side of the angle, which is 1, divided by the hypotenuse side of the hypotenuse of the triangle, which is root 2. And our value of cosine of pi over 4 is 1 over root 2. However, we're actually asked about cosine of negative 3 pi over 4, which is coterminal to 5 pi over 4, which is negative. So we have negative 1 over root 2 over here, which has the same value as 2 over root 2 over 2 if you want to simplify it any further. So we have root 2 over 2. As you can see, you can just leave it like negative 1 over root 2, but if you want to simplify it, you just times it by root 2 on both the numerator and denominator, so like the entire fraction still retains the same value, and you can write it root 2 over 2. And this is a simplification just because it is simplification conventionally. Conventionally, people don't like radical signs on the bottom of the fraction, but they want the radical signs on the top of the fraction if you need to have radical sign in your fraction. So that's why it is a simplification. Now let's look at our sample problems, our sample solution. So our sample solution here says that the angle is root 2 over 2, or sorry, the value of the cosine of negative 3 pi over 4 is root 2 over 2, which is not correct, because even if you're looking at the cosine of 3 pi over 4, it is still negative root 2 over 2. Actually, I think it's just the problem of the images, because if you zoom in, you can see a negative sign over here, and you can see a negative sign over here for the angles as well. I'll just leave this problem as like incorrect, although it's correct, and tell them in the comments that they should change the color of the negative sign because it's really confusing in my opinion. The solution is correct, but please or consider changing the color of the negative sign on the question and on the last line of the solution, on the last line of the sample solution. Currently, the color of those negative signs are both really faint gray and so are extremely difficult to see. Let's just say like this and put down the solution as incorrect temporarily so that they'll look at it and consider changing it. Nice. Now let's move on to our next problem, which is asking us for the square root of negative 81. So this question actually has two probable solutions depending on your schooling level. If you're like in primary school or middle school, you look at the square root of negative 81. You probably just want to say that the solution doesn't exist because you can't square root a negative number. But if you're if you're depending on what your teacher teaches you at the school and what you have learned recently, you can just say the solution doesn't exist because you can't square root a negative number, saying that is completely sufficient. But if you are learning about imaginary numbers and complex numbers in high school, saying an answer like that in like a complex number or imaginary number quiz is probably not acceptable, and you will probably mark wrong. So let's do the second case of imaginary numbers. So how do we do those problems if you have learned imaginary numbers or complex numbers? Is that you just you know that negative 81 is negative 1 multiplied by 81, and then you split the square root sign into both of its factors, and you have the square root of negative 81 is equals to square root of 1 times 81. And for 81 here, the square root of 81 is just 9, and the square root of negative 1 actually has a special name, which is I. So I is called the imaginary number, which just like its name, is not real, or it's not like on the real number line. So it is actually part of the complex numbers, because the square root of negative 1 actually doesn't exist as like values in the system of the real number. But when we extend the real numbers to include more numbers, we have the complex numbers, and the square root of negative 1, or I, is kind of the foundation of the complex numbers, which is very important in like a little more advanced math, or a little more advanced or a little more advanced physics. It's really used very often and happens a lot very often in how we try to explain the natural world. So basically 9 has a value of the square root of negative 1, and imaginary number square root of negative 1. So right over here for our problem, we just write down that is I and times 9, and 9 is just square root of negative 1. That's all there is to it for the sake of this question. So the square root of negative 81 is 9i. And this is our simple solution for this question, or this is our solution for this question. And again, we'll see what the simple solution says. Alright, they did it correctly, and they just wrote down the solution, or they just wrote down 9i for like the solution. So let's just say the solution is right. Great. And let's press the button that the solution is correct. Now let's move on. Now this question asks us what is the slope of the curve y equals x over x plus 1. So let's write down the question number. So our function is y, or let's say f of x, equals to x over x plus 1, which is the same as y equals x plus x1. I'm just using another notation right over here. Whoopsie, what happened? Nice. And you're asking for the slope of the curve at a point. So in order to find the slope, we would differentiate our function right over here. And how would we, and since our function f of x is like a division with two other functions, so let's just use the division rule, or I guess the quotient rule. That's what it's called. So let's just use the quotient rule. Use quotient rule for calculus. Use the quotient rule in calculus. So let's just use the quotient rule, or I guess more like functions, or I guess they can be called calculus. Okay, so it's basically the quotient rule. It basically states that the lower term multiplies the derivative of the upper term. So dy over, or I guess d over dx. So the d over dx of x minus the top term times derivative of the bottom term, which is x plus 1, the derivative of x plus 1, divide this entire thing divided by x plus 1, or the bottom term squared. So this is our how to apply the quotient rule. You basically just have the formula and you plug the top and bottom term into the formula and you just memorize the formula. In order to like solve this problem, there was like a little song that goes low d high minus high d low over low squared. And there's like a couple of different rhymes that can help you to memorize this formula more easily. But the one that I use is just basically low, meaning the lower term, d high, derivative of the top term. Low d high minus high, the upper term, minus high d low, the upper term, minus the upper term times the derivative of the bottom term over low squared, which is the bottom term squared. So yeah, that's how we solve this problem. And now let's further our simplifications. So the derivative of this is we just write down our bottom term first. And in order to find the derivative of x, it's just 1. So you just use your derivative rule of polynomials. And high, which is our x, times the derivative of x plus 1, which again is just 1, over low squared, which is x plus 1 squared. So we actually have x plus 1 minus x over x plus 1 squared. So our derivative of the function is just 1 over x plus 1 squared. And this is our derivative of the function. Now, we just need to plug in the x values to find the slope of the function at this point. So we don't even need to know the y values, but it was given to us anyways. So let's do f prime of x, which is 4 in this case over here. So we have f prime of 4 equals to 1 over 4. You plug 4 into x because it's f prime of x. It's the slope. So you plug 4 into x and we have 4 plus 1 squared on the bottom. So the slope in this case is just 1 over 25, which is equal to 0.04. Nice, and this is our slope. So our slope, oopsie, I don't want to spell slope wrong. The slope or the gradient, it's just 1 over 25 or 0.04 if you prefer decimals. Alright, so this is our solution over here. And now, let me see the sample solution. Yes, they actually wrote down the formula for the quotient rule, but you just plug in what we have for the top and the bottom term in the function, in the original function, and they did their thing, which is correct. And then let's look at their calculated results. It's not 1, so there's something that they did wrong. They substituted everything up to this point is correct, but they're trying to find the curve at the point 0.0 and 0.4, but we were asked for the point 0.4 and 0.4, and the point 0.4 is not even on the function, because when the function is at 0, when the x is at 0, the y coordinates is also at 0. So this function doesn't even go through 0 and 0.4. Oh well. So I guess I guess I'll just say something like the sample solution is incorrect. The question asked for the slope at x equals 4, not x equals 0. Correct result is 0.04 or 1 over 25. It's 1 over 25. Okay, and let's just say the solution is incorrect over here. Okay, so next up, it asks us the sine, cosine, and tangent function, whether they're odd or even. So you could have preliminary knowledge, and you can just say that that the sine function is I think the sine function is odd, the cosine function is even, which makes the tangent function the odd. So, but if you want, you could derive them using like basic trig identities, and also I think using negative trig identities, and also the concept of odd and even function. So let's just write down the concept of odd and even function. So for even functions, f of x is equals just to f of x, or sorry, f of negative x is equals to f of x. And for odd functions, f of negative x is equals to negative f of x. Also, we need a few other identities for like trigonometry. So what we do need is that sine of x is equals to, or I guess we don't even need to know about the odd and even functions, because we already know from the negative trig identities, or I guess, no, we do need to know that about them. Sorry, my fault. But from the negative trig identities, the negative trig identities, we know that the sine of x is equal to negative sine of x, and the cos of negative x, or the cos of x is equals to the cos of negative x. The cos of x is equals to the cos of negative x, and the tan of negative x is equals to, I'm sorry, the sine of negative x is equals to negative sine of x, and tan of negative x is equals to negative tan of x. So from here, we can already see that the sine of negative x, the sine of, which is the function of negative x, or the sine of negative x is equals to negative sine of x, negative sine of x. So sine is odd. And the cos of x is equals to cos of negative x. Cos of x is equals to cos of negative x. So cos is even. And the tan of negative x is equals to negative tan of x. So tan is also odd. And that's our answer. So our sine function is odd, so is our tangent function, but our cosine function is even. You can also see this by graphing them, but I'll just not like do it for you. So let's see. Yes, sine is odd, cosine is even, and tangent is odd. So the solution is correct. Let's see, the solution is correct. Good job. Nice. Let me check the time. Oh, we have still we are pretty much done for our live stream. So this is probably the last question that we're going to cover. So thank you for coming to OneClass live stream tonight. I hope you enjoyed our problem solving session. If you liked our videos, please hit the subscribe button down below, and I hope to see you in my future live streams. And have a great night, or I guess have a great day, depending on which time zone you're in. So I guess I'll just see you for now. Bye-bye.